Hello students, myself Professor Ashok M Jain. In this lecture, I am going to discuss about open delta, that is called as VV connection, and Scott connection of transformer. So already we have discussed the connections of three-phase transformer. Here we are going to discuss these two types of special connection, VV and Scott connection. Now what is a open delta or VV connection? Open delta connection can be used when one of the transformers in delta-delta bank is disabled and the service is to be continued until the faulty transformer is repaired or replaced. Right? इसका मतलब है अगर हमारे पास एक सिंगल फेज ट्रांसफार्मर के तीन ट्रांसफार्मर हैं, दे आर आइडेंटिकल ट्रांसफार्मर हैं, वी हैव ए बैंक, दिस इज कॉल्ड एज बैंक. And if you connect these bank in delta delta form, right, so it is called as delta delta transformer. If one of the transformer fails due to any reason, or if you want you can remove it, or if you want you can remove for the repairing purpose, या ऐसा कर सकते हैं कि अगर आप चाहें तो एक ट्रांसफार्मर को निकाल दो अगर लोड कम है. So in this case also three-phase to three-phase conversion is possible with the help of only two transformer. This is called as open delta or V connection. In that case, only it will supply the power to 57.7%. I will discuss how it is possible, but it is supplying power of three-phase to 57.7%. I'm going to. This is the delta delta connection, right? 1, 2, and this is the third one. Now I want to make delta. So how it is possible? This is A, capital A. This is connected to this and this is B. This is connected to this and this is C. And this part will be connected here. Right. Similarly here, this is small a, so secondary. This is connected to this, it is B. This is connected to this is C, and this part is connected here. Clear? It is forming a closed loop called as delta. So this is the delta delta formation. Right. Suppose this is 10 kVA transformer, this is 10 kVA, this is 10 kVA, and we have a three-phase load delta. This is the three-phase load, 30 kVA का load है. So load is of 30 kVA, and we are using three transformers of 10 kVA, 10 kVA, 10 kVA. So it will supply the power to the 30 kVA load. This is delta delta connection. Now suppose in place of 30 kVA, if load is reduced to say 15 kVA, load कम हो गया, तो भी क्या होगा, आप तीन ट्रांसफार्मर से सप्लाई कर सकते हैं. इट इज सिंपली वेस्टेज ऑफ मनी. आयरन लॉस विल ऑलवेज बी देयर, यू हैव स्टडीड. तो आप चाहो तो एक ट्रांसफार्मर को इफ यू वांट यू कैन रिमूव. राइट, यू कैन सप्लाई 15 kVA. You can supply three-phase power to the 15 kVA load with the help of two transformers, and this connection is called as open delta or VV connection. So I am just reviewing it. Right. So with the help of only two transformers, you can supply the power that is three-phase power. Okay, so voltage will be same, everything will be same, only we are using two transformer to supply the three-phase power. So this connection is called as open delta or VV connection, right? So this is the connection, we have a VV connection or open delta. But here it will supply the power that is 57.7%. इसका मतलब कितना सप्लाई कर रहा है? 30 kVA था ना पहले, it was 30 kVA. So it was 30 kVA. So 57.7, that is 0.577 of 30. It is approximately 17.7, 17.3 kVA it will supply. और अपना लोड कितना 15 kVA, so it is supplying more than that, so no problem. Transformer will not be overloaded, right? So this connection, so you can continue the supply with the help of only two transformers at reduced power. This much of power it can supply. Clear? So if the load is less, you can supply. Otherwise, अगर लोड पूरा है 30 kV है, तो आप उसको कुछ लोड को कम करके इस सप्लाई कर सकते हैं. Clear? So that is the open delta connection. Now I want to discuss some more facts. Okay. So please see here. I'm going to discuss. Let us say open delta. In delta connection, the voltage of any one phase at any instant is equal to sum of instantaneous voltage of the remaining two phases. इसका मतलब है at any phase, let us say VA, instantaneous voltage VA equal to क्या होगा? sum of VB plus VC, that is VA at any instant, you know. Okay, so in a delta connection, the voltage of any one phase at any instant is equal to sum of instantaneous value or sum of instantaneous voltage of remaining two phases, right? If any one phase is not working, suppose if it is not working this, so that remaining voltage will be same, it will not be affected, right? If any one phase is not working or one transformer from the bank is removed, the terminal voltage of the remaining two phases unaffected, right? You can see here the terminal voltage of the remaining two phases will be unaffected. This connection is called as VV connection. This connection is called as VV connection. So this connection कहाँ use करेंगे? This connection can be used when this connection will be used when first load is small. पहला condition क्या है? If load is small. And second condition क्या है? One of the transformer of delta bank failed. If one of the transformer of delta bank failed. So in this case, you can use this VV connection. Okay, so I want to discuss what is happening, how this transformer working. So I'm just going to make a delta bank. This is the delta bank, right? Okay, primary, and this is the secondary. This is the delta bank. This is the primary. Okay. Now, let us say this is the current I. This I is called as phase current. This I is called as phase current, and this current is called as line current. Line current. So you can say in case of delta bank, line current equal to क्या होता है? √3 times of phase current. IL equal to √3 times of I. √3 times of phase current. IL equal to √3 I. Okay. So this is happening. So in case of delta bank, if the line current of each transformer is I, line current is equal to what? √3 times of I. So KVA rating क्या होगा? KVA rating क्या होगा of each transformer? KVA rating of each transformer equal to what? V into I upon 1000. राइट ना? केवीए रेटिंग ऑफ ईच ट्रांसफार्मर, अगर सिंगल फेज ट्रांसफार्मर है तो वहां पर लाइन का कंसेप्ट नहीं आता, वोल्टेज इनटू करंट डिवाइडेड बाय 1000, इट इज केवीए. क्लियर? एंड टोटल पावर सप्लाइड बाय बैंक, टोटल पावर सप्लाइड बाय बैंक, टोटल पावर सप्लाइड बाय बैंक कितना हो जाएगा? √3 VL IL cos phi. In place of VL you can say same √3 V, that is V. Okay, √3 V. IL कितना होता है? √3 times I. Clear ना? So it is what? √3 into √3, 3 VI. If you divide by 1000, it is in kilovolt ampere. Okay, so √3 times VI cos phi. इसका मतलब है टोटल पावर क्या हो जाएगा? टोटल पावर इक्वल टू व्हाट? 3 times of what? 3 times of what? Rating of each transformer. Rating of each transformer. So 3 times of rating of each transformer. That is the total power supplied by transformer, right? Now I am going to discuss if one transformer is removed. Clear? If one transformer is removed, that is the total power supplied. इतना हो रहा है 3 VI upon 1000, that is in KVA, right? Now if one transformer fails, what will happen, right? So I am going to use another sheet. If one transformer fell, इसका मतलब है it is working as a bank. If it is working as a bank, so कैसे आएगा? It is like that. If one transformer fell, it is like that, right? That is primary. Similarly, secondary will be like that also. Secondary, this is the secondary. This is the secondary. Clear? Now this current was I earlier, अभी भी I रहेगा, right ना? Okay, that is also I. So यहाँ से क्या आएगा? Okay, that is I equal to what? Minus I1 minus I2, like that. That is instantaneous value. Anyway, so just what is the current? IL. IL equal to I. The same current will be here. So IL equal to here क्या हो जाएगा? I. Earlier it was a √3 I. इसका मतलब है current is reduced by √3. Clear ना? So line current. So line current is reduced from √3 I to only I. Current is reduced to root 3 I to I. It means current is reduced by 1 by root 3. 1 by root 3 मतलब कितना हो जाएगा? अप्रॉक्सीमेटली 0.423, 0.42 equal to 42.3%. So you can say the current is reduced by 42.3%. That is very very important. You must know it. Actually एक ट्रांसफार्मर कम होने से करंट कितने से रिड्यूस होना चाहिए? एक्चुअली आपका 3 ट्रांसफार्मर थे ना, इट वाज सप्लाइंग 10 10 10, बट करंट अगर एक ट्रांसफार्मर निकाल दिया तो इट शुड सप्लाई 66%, दैट इज 20 kVA, बट इट इज करंट इज रिड्यूस बाय 42.3%. इट इज नॉट रिड्यूसिंग बाय 33%. याद रखना. आप बोलेंगे सर एक ट्रांसफार्मर निकाल दिया तो करंट रिडक्शन क्या हो जाएगा? 33%. नहीं, इट विल बी रिड्यूस बाय 42.3%. ओके ओके. फॉर एग्जाम्पल, आई एम टेकिंग वन एग्जाम्पल. आई हैव 10 kVA के 3 ट्रांसफार्मर हैं, तो कितना लोड है? 30 kVA वी आर सप्लाइंग. ट्रांसफार्मर इज सप्लाइंग 30 kVA, बट इन ओपन डेल्टा, दैट इज वीबी कनेक्शन, 2 ट्रांसफार्मर बचेंगे ना, 10 kVA के 2 ट्रांसफार्मर बचेंगे, तो इट शुड सप्लाई 20 kVA. It should supply 20 kVA. That is what? That is 66% सप्लाई करने चाहिए था. 20 by 30, that is 66%. But it will not supply. But it will supply. It will कितना सप्लाई करेगा? It will supply only. कितना सप्लाई कर रहा है? 42 से रिडक्शन हो रहा है, तो it will supply 100% minus 42.3%, that is 57.7% it will supply. याद रखना. क्लियर? इसका मतलब है it is supplying only this, means in place of 66% it is supplying only 57.7. इसका मतलब कितना सप्लाई कर रहा है kVA? 30 kVA into 0.577, 57.7 मतलब 577. It is approximately 17.7 kVA. Right? This is the load it will supply. So याद रखना, जब ओपन डेल्टा हो जाता है इससे ज्यादा लोड नहीं होनी चाहिए, नहीं तो ट्रांसफार्मर क्या हो जाएगा? ओवरलोड हो जाएगा. Is it clear? So that is the concept I have developed from here. Okay, so this is the, it is supplying that much of load. Actually हो क्यों रहा है ऐसा? What is happening? Why the reduction is there? In place of 66 it is supplying only 57.7%. क्यों ऐसा हो रहा है? It is because of power factor of the load is changing. Are you getting it? This is happening because of power factor of load. Clear? Power factor of load. Power factor of load नहीं चेंज हो रहा. Power factor shared by transformers changes. That is very very important concept. Examiner may ask this question. Power factor shared by the transformer changes. क्लियर ना? सपोज करो पहले यूनिटी पावर फैक्टर था, यूनिटी पावर फैक्टर था, फाई कितना था? 0, cos 0 is 1. नाउ अभी 30 डिग्री से, बिकॉज ऑफ यहाँ पर जो फेज, यहाँ पर जो वेक्टर डायग्राम ड्रा करेंगे 30% से डिफ्लेक्ट हो जाएगा. सो पावर फैक्टर कितना हो जाएगा? 0.866 लीडिंग, एंड दूसरे का क्या हो जाएगा? 0.866 लैगिंग, and because of that reduction will be there. Are you getting it? So power factor is changing from unity से 0.866 leading, 0.866 lagging. Second case, suppose load का power factor of load कितना था? 0.866 था, 0.866 है suppose. So in that case, यहाँ पर because of open delta केस में both transformer will share 30 डिग्री से फेज शिफ्ट हो जाएगा. 0.866 का मतलब क्या होता है? 60 डिग्री. 60 डिग्री. cos फाई कितना है? cos फाई 0.866 है. सो फाई निकालेंगे तो फाई क्या होगा? cos ऑफ इनवर्स 0.86 करेंगे तो 60 डिग्री. तो यहां पर जो पावर फैक्टर चेंज हो जाएगा, इसका 30 डिग्री प्लस 30 डिग्री क्या हो जाएगा? 60 प्लस 30 90. cos 90 इज 1. एक का पावर फैक्टर 1 हो जाएगा और 60 माइनस 30 कितना हो जाएगा? 30 डिग्री. सो cos 30 इज 0.5. सो एवरेज पावर फैक्टर क्या होगा? पहले कितना था? 0.866. अभी कितना हो रहा है? कितना हो जाएगा? 1 plus 0.5 upon 2, 0.75. So because of that reduction will be reduced. Clear? Suppose करो तीसरा पावर फैक्टर अगर आपका सपोज करो 0.5 है. पावर फैक्टर लोड का कितना है? पावर फैक्टर ऑफ लोड कितना है? 0.5. फाई कितना है? 30 डिग्री. इन केस ऑफ ओवरलोड, इन केस ऑफ ओपन डेल्टा, पावर फैक्टर क्या हो जाएगा? प्लस 30 एंड माइनस 30. फाई कितना हो जाएगा? 30 प्लस 30 60 डिग्री. क्लियर? सो पावर फैक्टर क्या हो जाएगा? 0.866. सो 0.5 के बदले में 0.866. और दूसरे का पावर फैक्टर क्या हो जाएगा? 0.866 सॉरी 30 माइनस 30 दैट इज 0 डिग्री. फाई कितना हो जाएगा? 0 डिग्री. cos 0 इज क्लियर ना? So clear na? So one transformer will share load, another will not share load. So that is happening. So actually this reduction is because of only due to the change of power factor phi. 30 डिग्री का फेज शिफ्ट आएगा. सो वन ट्रांसफार्मर पावर फैक्टर अगर 0.866 लैगिंग हो जाएगा इन दैट केस, यूनिटी पावर फैक्टर केस में. क्लियर? एंड अदर विल बी लैगिंग. दूसरा केस अगर है 0.866 था, सो वन पावर फैक्टर विल बी यूनिटी, अदर विल बी 0.5. अगर 0.5 पावर फैक्टर था केस नंबर 3 हियर, सो वन विल बिकम 0.866 एंड अदर विल बिकम 0. इसका मतलब है एक ट्रांसफार्मर लोड शेयर करेगा, दूसरा जीरो कर देगा. इट विल नॉट शेयर. इट विल बी आइडियल इन दिस पावर फैक्टर. क्लियर? सो दिस इज हैपनिंग एंड बिकॉज ऑफ दैट पावर फैक्टर, because of the change in power factor, that is the reduction will be there. Clear? I am going to add one more sheet here. Now suppose karo I told you one example. I have 3 transformers of 10 kVA, 30 kVA. It was supplying 30 kVA and load कितना था? लोड 30 kVA है. सपोज फॉर एग्जाम्पल, इसका मतलब है 30 kVA सप्लाई है और 30 kVA लोड है. इसका मतलब है 3 ट्रांसफार्मर फुल लोडेड है, फुल्ली लोडेड, फुल लोड. लेकिन एक ट्रांसफार्मर फेल हो जाता है. सप्लाई कितना है? 10 इंटू 20 kVA. सॉरी, ये 10 2 इंटू 20 2 ट्रांसफार्मर है. लेकिन इट इज सप्लाइंग 20 kVA or not? No, it is not supplying 20 kVA. Clear? I told you already reduction will be there by some percentage. It is supplying only 17.7 kVA, 17.3 kVA. ये कौन सा है? ओपन डेल्टा VV कनेक्शन. और लोड सपोज करो, लोड कितना है? 30 kVA का है. लोड कम नहीं हुआ. अब क्या होगा? It is supplying only 17.7 kVA और लोड सेम है. So transformer will be overloaded. Both transformers will be ओवरलोडेड बाय, कितने से ओवरलोड हो जाएंगे, 1/0.577, दैट इज 1.732। इसका मतलब है बोथ ट्रांसफार्मर्स विल बी ओवरलोडेड बाय 73.2%। बोथ ट्रांसफार्मर्स विल बी ओवरलोडेड बाय 73.2% से ओवरलोड हो जाएंगे। बी केयरफुल अबाउट इट। और इन दैट केस अगर आपने लोड सेम है, ट्रांसफार्मर विल बी बर्न, ट्रांसफार्मर जलने वाले हैं, राइट। सो बी केयरफुल अबाउट इट, ट्रांसफार्मर में बर्न इफ we have not reduced the load. So this is the concept we have developed in case of open delta or VV connection. So इसमें इसका मतलब ये है, अगर आपके ट्रांसफार्मर डेल्टा डेल्टा फैशन में हैं या बैंक आप यूज कर रहे हैं डेल्टा डेल्टा फैशन में, और अगर लोड कम हो गया या एक ट्रांसफार्मर जल गया या फिर आपको इसके लिए यूज करना है मेंटेनेंस पर्पस के लिए, इफ यू वांट यू कैन remove one transformer, still it will supply 3 phase to 3 phase but balance load, right? So you can supply with the help of 2 transformer at reduced power, and power should not be more than 17.7 kVA, याद रखना, नहीं तो ट्रांसफार्मर ओवरलोड हो जाएगा। और फुल लोड है 30 का 30 है तो इट विल बी ओवरलोडेड बाय 73.2%, right? Now so I'm going to discuss one more concept, that is the Scott connection. So I am coming back for the Scott connection. Okay, so I am rubbing it. Open delta. Now second connection I am going to discuss, that is the Scott connection. Scott connection or TT connection. Again, this transformer, this 2 transformers are used in this type of connection. We can supply 3 phase to 3 phase with the help of only 2 transformers, right? This connection can also be used from 3 phase to 2 phase and 2 phase to 3 phase. So it is very important connection, clear? So you can supply 3 phase to 3 phase, 3 phase to 2 phase or 2 phase to 3 phase. It will require 2 transformer, one is called as main transformer and other, this is called as main transformer. You can see here, this connection is called as main transformer. Just wait. This is called as main transformer. You can say here main transformer, it is having 50% tapping, 0% tapping, 100% tapping on both sides, and also 50% tapping on both sides. This transformer is called as main transformer. The second transformer is called as 0% tapping, you can say 86.6% tapping, and 100% tapping also. I am not using like this, okay? 0% tapping, 86.6% tapping and 100% tapping, clear? So this is called as teaser transformer. So we have 2 transformer, one is called as main transformer, which is the main transformer which is having 50% tapping, and other is called as teaser transformer, teaser, which is having 0% and 86.6 and 100% also, but I am not going to use 100% tapping, 86.6% tapping, right? So this is called as teaser transformers. We are using 2 transformers here, clear? So what is the beauty of this? You can have 2 transformers, balanced load or unbalanced load, we can use this connection. It is more efficient, clear? But जो VV connection है, it should have balanced load. It can be used for balance and unbalanced load both. Both transformers should be identical. That is the condition we have. Both transformers should be identical. Okay. So you can make. So मैं ऐसा बनाता हूँ, एक ट्रांसफार्मर ये है, clear? Clear? And another transformer we have this one. क्लियर। यहाँ पर टैपिंग है वो 50% टैपिंग है। यहाँ पर tappings we have provided tappings 50% tapping. So this is connected to A, this is primary, this is secondary small a. इसका जो 50% है, let us say D part here, it is connected to say here it is connected. Clear? And clear ना? So इसका दूसरा part B है, here also B, और इसका सेंटर पार्ट यहाँ आया है और यहाँ से 86.6% टैपिंग ये वाली। See, this is 86.6% tapping. Here also 86.6% tapping here. This is brought out. Clear? और ये कनेक्शन कहाँ आया है? Right. So this is C. So in this way you can convert three phase to three phase with the help of two transformers. This is called as main transformer having 50% tapping, and this is the teaser transformer. Clear? Having the 86.6% tapping and 0% tapping or 100% also. But I am not going to use 100% tapping. Okay. So this is the Scott connection we have. Now I am going to use this connection. You can also, this is a three phase to three phase. It is three phase to three phase you will get. Three phase to three phase you can get from the Scott connection. Clear? Another connection we are going to discuss, that is called as three phase to two phase or three phase to one phase also. Actually it is converting not single three phase to two phase, it is converting three phase to two phase. So but two phase both will be separate, so you can say one phase and one phase. Okay, so that is called as, I am going to use it. It is separate sheet I am going to discuss. Just wait. Okay, I am rubbing it. Okay, so this is the three phase to two phase connection I am going to discuss, right? Three phase to two phase or two phase to three phase can also be possible. So let us say this is one transformer. Okay, this is the D point is there. Here also D. That is the 50% tapping. Right, 50% tapping we have. Clear? And this is the main transformer. Second transformer कौन सा है आपका? That is called as teaser transformer. Okay, so this is the 86.6% tapping. This one. 86.6% tapping. Here also. नहीं, sorry. So अगर आपको थ्री फेज टू टू फेज करना है, so it will not require any 86. It will require 100% tapping. Sorry, it is available 86.6% tapping, but we are going to use 100% tapping. So here this you can connect the load here, single phase load here also. On the secondary side you can have 100% tapping, that is the load you can connect. So you are getting two phases, one and one, two, one and one. You can say we are getting two single phase supply we are getting, right? And here that 100% tapping we are going to connect here. So here this is A, right? This is B, and this is 86.6% C. Primary side tappings will be 50% and 86.6%. Secondary side 109%, right? So this is called as main transformer and this is called as teaser transformer. So in this way we are converting three phase to two phase. You can convert two phase to three phase or three phase to two phase. क्लियर? क्या करना है इसमें? प्राइमरी क्या है, मेन ट्रांसफार्मर क्या है, 50% टैपिंग है, और जो टीजे ट्रांसफार्मर के प्राइमरी में वी आर यूजिंग 86.6% टैपिंग, बट सेकेंडरी में 100% टैपिंग वी आर यूजिंग. बी केयरफुल अबाउट इट. Clear? Now if you draw the vector diagram, this is D. Okay, so this is A. You can see the primary A, this is B. So A, this is B and this is D. You can say this is A, B and बीच में कौन सा पॉइंट है? D. So AD इसका कितना है? 50%. This is 50%. Clear na? 50 and 50. And D is connected to what? Here, right? And इसके बाद कौन सा पॉइंट है? C. So this is C. This is C, right? And here it is a neutral point. So this is the connection. Now what is the value of supply AC? ये supply क्या 3 phase देना ना? AB कितना है? AB equal to what? This A to B कितना है? This AD under root of AD square, AD, sorry, not, it is not under root, it is AD plus DB. 0.5 plus 0.5, right now? 50% 0.5 plus 0.5, it is 1. AC क्या होगा? AC equal to AD under root of AD square, because they are not on the same line. ये same line में है तो हमने कर लिया है वेक्टर सम. ये क्या होगा? AD square plus CD square. AD कितना? 0.5 square of that plus CD कितना? CD D. CD is what? 0.866. 0.866. So if you do it, you will get 1. और ऐसे सिमिलरली BC क्या होगा? BD मतलब 0.5 square plus CD 0.866. Again you will get 1. So इसका मतलब है this is the balance system. Clear? Balance 3 phase supply, you can get it, and you will get output single phase, 2 single phase output you will get. Clear? So but one more thing I want to tell you, the position of position of N point, ये N point है ना, तो you can see here the CN to DN. CN to DN. This CN position will be 2. ये 2 होगा, 2 to 1. याद रखना, अगर ये CD 0.866 है तो ये 2 times है और ये 1 times. Be careful about it, right? That is the neutral point you will get here. So that is the 3 phase to 2 phase or 2 phase to 3 phase connection. Application. What are the applications of this connection? So it will be used for electrical furnace. In industry हमारे पास कौन सी सप्लाई अवेलेबल है? 3 phase सप्लाई अवेलेबल है, right? We have 3 phase supply available. And in case of industry, suppose we have a furnace, it is running on single phase supply. Clear? और फर्नेस के लिए जो पावर रिक्वायर्ड बहुत कम नहीं है, बहुत ज्यादा पावर लगता है. और आपको अगर दैट फर्नेस इज रनिंग ऑन सिंगल फेज, एक फेज आपने एक फर्नेस को दे दिया तो क्या हो जाएगा? पूरा का पूरा सिस्टम क्या हो जाएगा? अनबैलेंस. क्लियर ना? तो यू विल अवॉइड, suppose you want to avoid the unbalancing, what you will do? You can give the supply to the furnace from the Scott connection. एक यहाँ पर आप फर्नेस लगा दो, so system will not be unbalanced. Clear? आपके पास 2 फर्नेस हैं, one furnace will be supplied from here, other furnace will be supplied from here. So in this way, this Scott connection can be used. Clear? To make the system balance. Similarly, electric local traction purpose, in electrical traction. जो इलेक्ट्रिकल ट्रैक्शन में आपको मालूम है, जो सप्लाई हम देते हैं वो 132 किलो वोल्ट देते हैं रेलवे में सबस्टेशन को। और कौन सा सप्लाई देते हैं, सिंगल फेज की थ्री फेज? सिंगल फेज। अगर आप 132 केवी पावर आपने 130 वी हैव गिवन पावर और दैट इलेक्ट्रिकल सिस्टम और इलेक्ट्रिकल रेलवे और इंडियन रेलवे, दे आर टेकिंग ए पावर सिंगल फेज पावर, दे आर नॉट टेकिंग ए थ्री फेज पावर। अगर आपने थ्री फेज सिस्टम आपका आया है और उसमें से सिंगल फेज सप्लाई आपने रेलवे को दे दिया, तो सिस्टम क्या हो जाएगा, पूरा का पूरा सिस्टम क्या हो जाएगा, अनबैलेंस। एंड सिस्टम अनबैलेंस हो गया तो क्या होगा, नेगेटिव फेज सीक्वेंस करंट कैन फ्लो देयर। क्लियर? यू विल स्टडी नेक्स्ट ईयर इन पावर सिस्टम 2। So we have to avoid this unbalancing. So क्या करना है आपको, we have to give the supply with the help of Scott connection. So Scott connection will be used, three phase supply देंगे, up will be connected here, down will be connected here. So single phase supply, electric traction में single phase supply ही देते हैं, याद रखना, to make the system balance, right? So this connection will be used in electric furnaces and electric traction, etc. Okay, so that is Scott connection I had discussed, and this is more beneficial as compared to the VV connection. It can be used for balance as well as for unbalanced system, but both transformers should be identical. Right? Now I am stopping here. Okay, and in the next lecture we'll discuss about parallel operation and polarity test. So we will discuss that part. I am stopping here. Clear? Thank you very much for listening me carefully. Thank you.